students, in this video we are going to look upon how to generate a toolpath for a particular what we can say job which is to be performed on a CNC machine. Now in order to generate the toolpath virtually, we need to use a software which supports computer aided manufacturing. So there are various softwares available, and out of that I am going to showcase upon Autodesk Fusion 360, a very well known software, and it's accessible free of cost for university students and all those who are a part of any college or any university. The link to download the software and to get register yourself for free, I'll be putting it into the description of this video. So let's get started. Now before generating, now the basic reason of what we can say, or the output of this particular practical, is to generate the toolpath virtually by using the CAM software. Now before generating the toolpath virtually by using the CAM software, what we need to have in hand is a CAD model. So here what I'm going to do, I'm going to consider a job with respect to CNC milling machine, and I'm going to first generate the CAD model of that particular job, and then I'm going to perform the operations by using the CAM software. And both the CAD as well as CAM, that is computer aided design and computer aided manufacturing, are included in the same software, that is Autodesk Fusion 360. And that's the reason I have chosen the software, since it is easy to what we can say transfer it your what we can say model from CAD to CAM. And so let's get started. So as soon as you open your Autodesk Fusion 360, you log in into it. Okay, so here in the top right corner you can see your name over here as soon as you log in, and this is the basic data panel, or you can say, sorry, this is the basic user interface that you can see over here. Now from that, very first important thing is your data panel. So you can click over here, show on data panel, and in this you can create your new project. Okay, so I will click on new project, and from here I will give the name of CNC Milling. Okay, you can give your own name and you can just click on OK. So that particular project will be loaded. Now whatever file I am going to generate over here, I will generate under that particular model. Now in order to get a new model, or the what we can say, in order to start with my design, before going towards that, what we need to do is we need to do certain initial settings. So this is the what we can say workspace, and this is a cube you can see over here. So by default, this is your top view, this is your front view, this is your right view. So everything looks okay, so no need for any changes with respect to this orientation. Now I am going to select the document settings. So under document settings we have the options of units. So since the model that I am going to CAD model that I am going to generate is having the units in mm, so here I need to keep it in mm. If you are working in any other units, so accordingly you can change it from here by clicking on this change active units, and from here you can see you have the different options to change the units. Okay, so since I am going to work in millimeters, I am not changing it. Now since I am going to generate a CAD model for a CNC milling job, so every one of us know that with respect to CNC milling, basically the operations happens along the surface of your what we can say workpiece. So definitely your workpiece, the workpiece that I am going to draw, I will start with the top plane. Okay, and in the top plane I will draw the 2D sketch, and then I will extrude it, and I will get the 3D model with respect to whatever my job is there. So from here I am selecting the top plane. Okay, as soon as I select the top plane, now one more important thing I forgot to tell you, that here you can see there are the different workspaces which you can utilize with respect to your Fusion 360 software. So there is design, generative design, render, animation, simulation, manufacture, and drawing. Now in this video we are going to cover two of it. First one is your design, wherein we generate a CAD model, and the second one is your manufacture, wherein we will stimulate the different manufacturing operations. Okay, other options you can definitely go and check for what exactly it is used and how we can use it. Okay, you have the free tutorial videos of Autodesk Fusion 360 on the website itself, so you can go and practice if you are interested into this generative design or rendering or animation. So I have selected the top plane. I will double click upon it. After I double click upon it, what we can say, it zooms out into the screen. Now from under solid, I will select create sketch. As soon as I click on create sketch, here a window pop-ups, or what you can say, a plane pop-ups. So I need to double click upon that plane, and as soon as I double click upon that plane, now I can see the coordinates. Now the job that I'm going to, what we can say, draw or design, it's actually whatever drawing I'm having at my reference end, it is in the second quadrant. So I'll start drawing it. Okay, so I've selected the line option from here. So I will click upon over here randomly, and afterwards I will give the unit. Now I will select a straight line. The distance of it is 100. Okay, so if I want to continue with the line option, so what I need to do is I just need to enter the value, and I need to go for single click. If I want to discontinue, then I need to click on enter. So as soon as I click on enter, the line option will discontinue. Okay, now I want to give this initial dimension over here. So here you have the option of sketch dimension. If you don't found this sketch dimension over here, you can go into this create option, and here also you can find the option of sketch dimension. Okay, so since I already have the it loaded over here, I will choose it from over here, and by using that I can give the dimensions. So I have selected these 2 points, and I want to set this distance as 30. So I have selected this. Now what I will do is I will click on escape. If you want to come out of any option, you need to just click on escape. I will now again continue with the line option. So I have selected the line option. Now it's vertical. See, it will show you the angle also, as well as you can enter the value of the length of the particular line. So this is my 110. Okay, I'll single click. I'm continuing with the line option. Okay, and this is my 80. Okay, yeah. Now there is what we can say, a center point arc over here. So what I will go is, I will go into create. I will go into arc, and I will select center point arc. So I'll click it over here, click it here and here. So okay, I'll just made a mistake. I'll click on Control Z. Again I will go for the create center point arc. Selected this. Okay, there is some mistake with respect to my dimensions. I just need to check it. Yeah, my dimension has been, I have made a mistake over. I will just cross check it. So this is my 80 plus 30, so it comes out to be 110. Okay, this is okay. I will continue it from over here. This is my 130, right? And this is my 80. Okay, just check the dimension over here. Let me see what I'm going wrong with. 30. Yeah, now it's okay. So now we'll go for the arc, create center point arc. So here I have selected this, I have selected this point, and then I have selected this point. Okay, now once I have created this sketch, if I want to check whether there is something there is pending with the sketch, I will just move on the cursor upon the sketch. So here I can see everything has turned out to be black. So black indicates that it is fully defined. No need to give any more further dimensions. Okay, now there is a fillet over here at this corner. So I will select the option of fillet from here. I will select this edge, and then I will select this second edge, and the value over here is 20, radius is 20. So I'll click on 20. Okay, now it is okay. Now I want to extrude this. I have done the 2D part. Now I want to convert this 2D sketch into 3D. So for that we need to shift from sketch option to solid option. So for that you need to first click on finish sketch over here. As soon as I click on finish sketch, okay, now we come to the options of solid. Now in order to extrude this, I need to change the view of this. So what I will do is, here you can see the home position. above the cube. So you can click upon that home position. So now we can see the top plane, and now the orientation is okay. So I will click on extrude. Now I have with 20 mm thickness. So I've selected 20 and I'm going to extrude from the top on the upper side. So that's the reason I've chosen the arrow on the upper side, and I'll click on OK. So I have extruded this. So now it has turned to be 3D. Now there are two more features additional to this. There are three holes over here and there is a slot also. So what I will do is I will click upon this plane, okay, and then in solid option only we have an option of hole, okay. So I'll select that. Now I want to set the distance. Now again I will change the view. So I'll select the top view. Now it is asking me to select the reference, okay. The face has already been selected. Now I'm selecting the reference. So this value, I'm selecting it from this edge. The value is 130 minus 25. This is as per my drawing, okay. Okay, I've just clicked the option of enter, so that's the reason it has gone. So I'll click it over here. I'll click on edit, or also I can do undo. Okay, now I'll select the whole feature. I selected the face. I will select the reference. So first reference is from here. This value is my 25, and then in reference second I will select this edge, and this value is my 30. You need to select the references from both the edges. Now the hole type I'm going to keep it simple. Hole tap type also I'm going to keep simple, and drill point I'm going to keep flat. I don't want a taper drill. Okay. Now this is a throughout hole. So my plate thickness is 20 mm. So I need to enter a value more than 20. So I'll use here 25. And as per my drawing, the radius of the hole is 8. So the diameter will come out to be 16. So I'll enter the value of 16 over here, and I'll click on OK. So here you can see the hole has been generated. I will change the view. I will click on home position. So here you can see the hole. Now I want two more holes of the same size, same depth of hole depth. So I'm going to use the pattern option. So here in solid you can see the option of rectangular pattern. So I will select that. Now it is asking me the object to be selected, that is to be pattern. So I will select this hole. Then it is asking me the direction in which I need to create the pattern. So I will select the direction along this edge. So since it is in this angle, then the distance type. So as per my drawing, I am having the distance of center to center. So this is the spacing I will select, and there are total three holes. Yes, that I want to generate, and the distance between the hole centers are 30, equally spaced. So see, you can see the three holes over here. So this is what is there according to my drawing, and if it is okay, I will click on OK, and then I will see that the same type of two more holes are generated over here. Now there is one more feature which is need to be added according to my drawing, that is a slot. Now in solid option you don't have the option of slot directly. So basically what you need to do is you need to draw the sketch, and then you need to extrude it. So what I will do, I'll click on this face, right click, and I will click on create sketch. So I've selected the face and right clicked, and I've gone for select sketch. Now under this I will use create option, slot, and I'm going to use center point slot. Randomly I will click it somewhere over here. Afterwards I can give the distance. Now the center to center distance of the slot is 25, so the half distance will be 12.5. I'll click over here, and the radius of the slot is 6, so the diameter will be 12. Okay, once I have done with this, I need to set the location of the slot. So it is exactly at the center from both the ends. So I'll click on this. I'll select the center of the slot at this value, and this was my actually 130. So this is my 130 divided by 2. Okay, and then the second dimension with respect to this edge. So this is my 110. So this is my 110 divided by 2. So as for my drawing, I have set the location. So now I need to extrude this. So I need to click on finish sketch. Now I will again click on home position, okay, so that I can view it properly. Now there is no option of extrude cut as in other softwares. Here you need to use the option of extrude only. So I will click on extrude. Okay, now it is asking me which profile do you want to extrude. So I want to extrude this slot, so I will select the slot profile. Now there is a depth of the slot is 10 mm below the surface, so I will take the arrow downwards by just what we can see by pulling your mouse click, and here I will give the distance of 10 which is required. Okay, so and I will click on OK. So now the slot has been generated, as you can see over here. So this is my actual CAD, what we can say, or this is my CAD model as per the drawing which I have with me for reference. You can create your CAD model as per the drawings that you have, and you can practice for the same. Very easy to generate what we can say your CAD models by using this software. Now we are done with the CAD part. Now we will move on to the CAM part, that is your computer aided manufacturing. And what we need to do is we need to generate a tool path for this particular job. So looking at this job, basically we need to first decide that what kind of operations will be required to what we can say to get this job done. So looking at this job, the first important thing is that the raw material which will be required will be a rectangular block, and then we will perform the operation. The very first operation that we will perform is we will do the facing on the top face, and we will remove the extra material. Then we will do this counter what we can say profiling or profile milling, that is along the counter of your job, and we will remove the what we can say extra material. So the first operation that will be performed is facing. The second operation that will be performing is counter milling. Then the third operation will be performing is drilling, and the last operation that will be performing is slotting. Okay, so basically these four operations we are going to perform, and I need to generate the tool path for all these four operations. So let's see how to do this. So once we have completed with the design part, we will click on this workspace and we will go to manufacturing workspace. So as soon as I click on manufacturing workspace, here you can see the manufacturing options are highlighted: milling, turning, additive, inspection, fabrication, utilities, and there are multiple other options also available over here. So now since this is a milling what we can say job, so I need to click on milling. And initially the very first thing that I need to do, that before simulating my manufacturing operations, I need to first do the setup of the job. Setup of the job involves my selection of machine, my selection of raw material, what size of raw material I'm going to use, and what all other things I need to initially set up. So I click on setup under milling. As soon as I click on setup under milling, this pop-up opens of the setup. Under that, first I need to select the machine. So I will click on select machine. Now there are some machines which are by default available in the Fusion 360 library. If the machine is not available, not a major issue. Okay, you can go to the Fusion 360 library and search the machine. Okay, and as per your requirement, you can what you can say select the machine. So I am going to use this machine, that is a generic 3-axis machine wherein you have X, Y, and Z axis on the head. So I'll click on select. So the model for this machine must be downloaded before it can be used in the simulation. So I will click on download model. Okay, I'll click on save. Okay, so if the machine is highlighted, it's okay. If it is not highlighted, that is also not a major issue. I'm getting an error over here. So that is depends upon sometimes the file, that whenever you are installing this software, if the particular file is missing, it may not be installed properly. So not a major issue. Our main thing is with respect to the job setup. So if your machine is being getting selected, well and good. If it is not getting selected, not an issue. Now the next important thing is operation type. So under that we have selected milling. Next is your coordinate system. Now this is very much important. Now as per the drawing that is provided to you, you need to select the coordinate system. Now the drawing that I have with me, the 0, that is your program 0 is at this point. Okay, since I already told you that while drawing we drawn it into the second quadrant. So if you consider this as a second quadrant, then this is your origin. So right now by default it has taken this origin, so I need to bring it at this point. So here you can see under stock point the box point is selected. So I'll click on this box point where I need to shift the origin. So as soon as I click on that point, the origin has been shifted and it is okay. Your axis in this direction, Y is in this direction, and your tool will be along the Z direction. So my orientation is okay. Now under body model, I'll going to select body option. So as soon as I select the body option, my entire body gets selected. So in this very first option, what we have done is we have selected the machine, and then we are located our program 0, and we have selected the body. No, there are some extra features also over here like fixture and all, but this comes into picture when you're actually going to do the manufacturing after doing this computer aided manufacturing. So right now just we are looking into the basic part, so we not go deep into this option. Now the second option is your stock. So what kind of stock you will have? So definitely we need to take some relative size of stock. So that's the reason under mode we have a relative size. Now side offset. So what I'm going to do is I'm going to take 10 mm extra sideways. So I will increase this value to 10. So as soon as I say, as soon as I've increased the value 10 side offset, from all the sides 10 mm extra, we have got the raw material. And top also I'm going to take 10 mm extra. So from here I will what we can say, increase the value to 10. So from the top surface also there is a 10 mm extra material. So this top surface 10 mm extra material will be removed by facing, and the sideways 10 mm extra material will be removed by profile milling operation. Now bottom offset I am not going to take because I am considering that the bottom is directly attached to my table, workpiece table, my what you can say machine table, and so I don't need to have extra material at the bottom. So no other changes need to be done over here. I have stock width I have already selected. Now the next is my post process. Now this is very important. So under post process, the program number, here you can enter your number of any choice. Now program command, under program command I am giving the name as CNC Milling, and I will click on OK. Okay, so the setup has been done. You can see the raw material that has been highlighted, which is transparent, and the dark color is your actual job, okay, or the product. Now the very first operation, as I already discussed, that we are going to do is milling. Okay, so under this milling, as you can see over here, we have 2D option, and under 2D option we have the option of face. So since we are going to do facing initially, so I will select this face under 2D. Now from the very first thing I need to select is the tool. So I'll click on select. Now under this I need to select the tool. So there are multiple filters available over here. So I'll click milling over here. Now the type of tool that will be used for facing is my face mill. So from here I will select the face mill option. Below no more settings I am going to change. Under unit I am going to select millimeters. Then there is a Fusion 360 library over here. So let me check whether there are tutorial metric. Under tutorial metric, yeah, under tutorial metric we have a tool of 50 mm. Now the size of the face mill does not depend, does not affect over here, because since we are going to remove the material from the top surface, so not much of a issue with respect to size. So there is since one only tool available in the library, I am taking that tool and I will click on select. So as soon as I click on select tool, okay, your tool gets highlighted over here. Then no other settings I'm going to change over here. By default the feed and the speed I'm going to keep it same. Now next is your heights. Now in order to see its heights clearly, I will go to front view. So these are your different heights. There is a clearance height, okay, then there is a retract height, there is a feed height, there is a top height. Okay, now these are the different heights which are given in order to ensure that your tool moves properly with respect to workpiece. Your tool does not hit the workpiece during the operation. So in this, not a major change I'm going to do. I'm just going to do is the very first height, that is your clearance height, it is 10 mm. So I'm reducing it to 5 mm. So you can see that orange color layer will come little downwards. So this is just I'm ensuring to have a less number of tool travel, nothing else. You can keep 10 mm also, no issue with that. No other setting I'm going to change into this. Then there is a next option of passes. Now it is asking me pass direction reference. So now I'll again go to home position by clicking on this home. Now the direction of pass I will select this direction. So what happens, as soon as I select this direction, my tool will move along this, what we can say, path. So it will move from this origin to this line, again it will come over here, so it will go that way. Okay, if I select this edge, so my tool will move this way. Okay, So that is not a major issue. Okay, so I have selected the part direction. If I want multiple depths, so definitely I can select multiple depths. So in multiple depths my cutting will happen. Okay, so right now I'm not going to select multiple depth, not bigger cut, only a 10 mm cut. And then the last option of linking I will keep by default whatever it is. Now I'll click on OK. Now as soon as I click on OK, you can see that the setup has been done for your what we can say facing operation, and here you can see the toolpath has been generated. The blue color thing is nothing but your toolpath. Now the toolpath is generated in this line. The reason is I have selected this edge as a what we can say reference to travel. Now I can simulate this. So in order to simulate this, what I will do is I will right click on this and I will click on simulate. As soon as I click on simulate, the pop-up opens for the simulate option. Now under this, I need to tick on tool, then the tool will be visible. I need to tick on toolpath so that the toolpath will be visible while I simulate. I need to tick on stock. Now most important option over here is this colorization. Under colorization of the stock, I need to select comparison. Due to this, what will happen is your stock and your raw material, sorry, your stock and raw material is same, your stock and your final product, it will be shown in different colors, so that it will be easy for you to identify whether the machining is happening proper or not. And then under this model opacity you can select over here, no issue with that. Now here is a option of play and here is the option of speed adjustment. So you can move this cursor towards and backwards and you can see the facing. Okay, so here you can see the facing happening, and as soon as, since I have not used multiple depths of cuts, only in one cut the complete facing has been happened. And see, now you are seeing a surface with a green color. So green color is nothing but your final product. So the facing is happening properly, the top face has been got clear. So I close this from here. Now the second operation that I need to go is for this counter what we can say profile milling. Now for that, under 2D we have two different options. One is our 2D adaptive clearing and the second one is 2D counter. So generally if the surface is at one level only, we go for 2D adaptive clearing. If there are certain changes in the layer height of the surfaces, then we go for 2D counter. So now since our surface is uniform, I will be going for 2D adaptive clearing. So I will click on 2D adaptive clearing. As soon as I click on that, my pop-up window is open. Now I need to select tool for this. Okay, so I'll under the tool I will go on select. Under this what I will do, milling. Now for profile milling, I can't use the face mill tool, I need to use the end mill cutter. So from here I will select flat end mill. Okay, under my filter, and from here under unit I will select mm. So I have selected millimeters over here. Again I will go to my sample tools metric. If there are some tools available, yes. Now the tool that I am going to select, now here the size matters. Now sideways I have taken 10 mm extra material. So definitely the tool that I will be using should be minimum of 10 mm diameter. Okay. But now there is one more option, one more operation that is we need to do, that is of our slotting. Now in order to carry out that option of slotting, what we need to do is we have the slot diameter of 12 mm. Now for slotting and for profile milling we can use the same tool. So that's the reason what I'm going to do is I'm going to use a 12 mm flat end mill. So what will happen is by using this tool I can carry out both the operations. I can carry out my profile milling also as well as my slotting also. But right now I'm doing profile milling. So as soon as I select 12 mm tool, below you have different options. So from that now I will not select slotting over here. I will select aluminium roughing or finishing. Now this aluminium is nothing your material. Okay, so depending upon your what kind of job you are doing, you can select the material. And now I will select just a minute, I have taken the screen little low. Okay, now I'll click on select. Okay, so as you can see the tool has been appeared over here. No need to change any other setting over here. Then I will go to the geometry. Now it is asking me the pocket selection. Now this is very important. Pocket selection you can see over here. As soon as I keep the cursor, the description comes out. So this is very interesting thing about this software, that if you are not getting exactly what option to use, you can just bring your mouse cursor upon that particular option. It will show you the entire details that what exactly this option does. So by reading that, if you have a technical knowledge, definitely you can select that particular option. So now pocket selection is nothing but, since you are going to do profile milling, up to what depth we need to cut this. So we are going to cut up till the bottom. bottom edge. So what I will do, under pocket selection, I will select this bottom what you can say plane. So as soon as I select the bottom plane, it will give the reference that my tool needs to travel up to this plane in order to give the profile cut. Okay, no other options I will select over here. Then under heights, again in front view, if we see that then this clearance height is little bit away, so I will reduce it to 5 mm. Okay, next is your passes. So in passes, what I will do is I will untick the stock to leave. Okay, because I don't want to keep any stock. I can activate this multiple depths so that my profile milling happens in multiple depths. Okay, and if you don't want, not required, since your less amount of material is to be removed, so no need to take that. And now I'll click on OK. I'll click on home position, so my toolpath is visible. So as you can see over here, this is the toolpath that has been generated for your profile milling. Now the same procedure, will right click on this and we'll click on simulate. Again your same window will open for simulate. Now again you need to assure that you have ticked the tool option, you have ticked the toolpath option, you have ticked the stock, and under colorization you have selected comparison. Okay, and now you can click on play option. A little slow down the speed. I'll click on the play option. Okay, so a little bit faster way. So this is your profile milling, as you can see, or you can also call it that counter milling or adaptive clearing. So it is removing your materials along the counter of your workpiece. Okay, so as you can see, earlier it was blue color, now it has turned to be green color, and everything has been turned green properly along the counter. So that means my profile milling has been executed very well. Okay, this is done. Now we'll go to the next operation. Now our next operation is drilling. So with respect to drilling, no need to go for this 2D option. Directly you have the drilling option over here, and you can see the drill over here. So I'll click on this drill. Now I need to select tool, so definitely I need to have the tool with respect to my drilling. So under this hole making, I am going to select normal drill. Okay, and under that, beneath, I will, under unit, I am going to select mm. Okay, now the hole size, that what we can say, with respect to my drawing, is the diameter is 16. So again under sample tools metric, I need to select a 16 mm, what we can say, drill. So I will scroll it down over here. I have a 16 mm drill. Okay, and then depending upon material I can select it. So I am selecting by default aluminum. So I'll click on select. So my tool has been selected. No other setting needs to be changed over here. In the second, geometry. Now this is very important. What it is asking us, hole faces. So I need to select this hole faces. Okay, now the next option, select same diameter. So all these are of the same diameter, so I'll click on select same diameter. Then all these have the same hole depth, so I'll also click on select same hole depth. Then all these have the only same Z height, so that they're in one level only, so I'll take also that. And then nothing else to be, what we can say, choose from here. Only one option that I need to get into is, let me check if there is. Okay, no, with respect to tool orientation. Now with respect to height, all these are again your heights with respect to, what we can say, uh, the earlier one which you taught. Now in this case, I am not going to reduce this clearance height. The reason is, as you can see, the drill tool length is, what we can say, much larger. Okay, so definitely it will require that much amount of space. So I will not change the clearance height over here. Only one thing I need to change is, as you can see from the diagram over here, by default the drill that will be generated is a tapered one, so it is not going to be a through drill. So if I want a through drill, then in this what we can say height option, there is a last option, that is drill tip through bottom. So I'll tick on that. Please observe, as soon as I tick upon this, your hole becomes a through hole. Okay, and then I will click on OK. So my settings has been done. I'll click on home position. Here you can see the toolpath that has been generated. I'll click upon this again. I'll click on simulate. Okay, so again the same settings, and I'll click on play. Okay, so as you can see, little slower I will make it. Earlier it are blue color, and then the drilling operation is happening and it's turning out to be red color. You can see it in the front view. Here you can observe that it is what we can say generating a through. Here you can see it is coming throughout what you can see your workpiece. Okay, so our drilling is done. I will close this, again come back to my home view. I'll click sideways, or I can click escape to come out of that particular option. So now the last option that is pending is your what we can say slotting. Okay, so to generate this slot under 2D, we have the option of slot. So I'll select the slot over here. The very first option, it is asking me to select tool. So now recently I have used two tools, that is my flatten mill and face mill. So I'm going to select this flatten mill. The reason is I have selected 12 mm flatten mill because I wanted to do both the operations, counter milling as well as my slotting. So that's the reason I have selected the same flattened mill. And now from here I will select slotting. I'll click on select. Now here 12 mm, the reason I have selected because the diameter of the slot is 12 mm. Okay. Then the second option, again here it is asking me pocket selection. So once the slotting will start from the top surface up till what height it needs to go. So for that I need to select the bottom, what you can say, plane of the slot. So this is the bottom plane. So it has got selected over here. Next option is your height. Now in this case you can reduce this clearance height if you want, if you think that it is much away. Okay, and then no other options need to be changes. Under passes, okay, you can keep multiple depths, and if you want, no need for single depth. And smoothing you can keep over here. So I have ticked up on multiple depths, I have ticked up on smoothing, and by default whatever values are there I have kept that values. I'll click on OK. The safe distance is higher than the feed, consider reducing the safe distance. Okay, so there is a value which has turned out to be red color. Now if you don't technically know how to reduce this value, you can just right click on this and click on reset to system default. So as soon as I click on reset to system default, okay, it is not changing. So what I will do, I will reduce the value from over here. So as soon as I reduce the value, you can see it has turned out to be black color. So now the value is okay. So I'll click on OK. Yeah, so here you can see the toolpath is generated in red color. Now again the same procedure, right click, I'll click on simulate. Okay, I'll click on play button. Okay, now earlier the toolpath has been generated in air a little bit. I'll make it a little faster. Okay, little bit slower. Let's see it again. Okay, so this is nothing but your slotting operation. The reason it has started from a top surface a little away is depending upon your clearance height. Okay, nothing else. So here your slotting has been completed. Earlier it was blue color, now it has turned to be green color. So now your job has been perfectly made. So you can close this. Now if you want to observe all the what we can say simulations at one time, here you can have under actions simulate. Okay, and then you can just play. Okay, you can also switch between operations, go to next operation if you want to directly know the next operation. Again, if I click on next operation, it will show me drilling, and on next operation it will show me slotting. Okay, so there are different options available in this. So this is how we have generated a tool path with respect to what we can say different geometries. Now if I select all this, you can see that the toolpath with respect to all operations. Okay, so I've just click on control and I selected all. You can see the toolpath. So this is your facing, this is your profile milling, this is your drilling, and the last one is your slotting. Okay, so we have successfully generated a toolpath for our CAD model which was of our interest. So thank you for watching. If you have any other doubt, you can definitely ask me into the chat box. Thank you.